Ions are what form when you have an atom and you either add or remove electrons. An atom can either gain an electron or lose an electron, or gain multiple electrons or lose multiple electrons. When an atom gains electrons, it's gaining negatively charged particles, which throws the balance of protons and electrons out of balance. And you have more negative charges than you do positive charges. So an atom that gains electrons will now have a negative charge. And these negatively charged ions are called anions. When an atom loses one or more electrons, it results in a structure that has more positive charges than it does negative charges, and therefore the overall ion will be positively charged. And these positively charged ions are known as cations. So for an example, we can look at the chlorine atom. Chlorine has 17 protons and 17 electrons, and some unimportant, for this purpose anyway, number of electrons. 17 protons and 17 electrons makes that electrically neutral, and if you add one electron, you end up with a Cl- ion. So I've written add one E-, E- being a symbol for an electron. And now that there's a negative charge, you should show that charge in the upper right-hand corner of the elemental symbol. If we wanted to add more than one electron, we could use an example of something like the nitrogen atom. Nitrogen has 7 protons and 7 electrons. And if we added 3 electrons to nitrogen, we would have an ion that has a 3 negative charge. Similarly, we can take away electrons from an atom. So if we look at the sodium atom, it starts with 11 protons and 11 electrons, so electrically neutral. And if you remove one electron, you now have 11 protons and 10 electrons, so you have a 1+ charge. Now when you're adding or moving electrons, you can't do this randomly. Under general circumstances, you cannot add 6 or 7 or 12 electrons, for example, to a chlorine atom. Chlorine will typically only accept one additional electron. And similarly, you can't actually take away a more or less random number of electrons. So for chlorine, it's actually very difficult to take electrons away from it, so chlorine typically doesn't end up as a cation. Typically, if chlorine makes any ion, it will be the Cl- ion. And later on, if you learn about electronic structure, you will find that there are ways to predict how many electrons can be gained or lost. But for now, we can give you a simple rule of thumb. And the rule of thumb that we can give you is metals tend to lose electrons, and they make cations, while nonmetals tend to gain electrons, and they make anions. So there are a few groups of the periodic table where you can make pretty consistent predictions. Everything in the alkali metals, that's group number 1, when they lose electrons because they're metals, they typically lose 1 electron, and they make ions with a single positive charge. Everything in group 2, that is the alkaline earth metals, they typically lose 2 electrons to make 2+ cations. And at that point, the pattern falls apart. If you look at the transition metals, the trend doesn't continue with +3, +4, +5, etc. Some of the transition metals can actually lose different numbers of electrons depending on the circumstances. So certain elements, such as iron, can form a 2+ charge or a 3+ charge, and it's really very situationally dependent. So there's no great rule of thumb. If we look at the nonmetal side, the noble gases typically don't gain or lose electrons at all, so they don't typically make ions. If you look at the halogens, they typically gain a single electron to make a -1 anion. If you look at the chalcogens, the oxygen group, they typically will gain 2 electrons to make a -2 charge on their anions. And if you look at nitrogen, it typically gains 3 electrons to make a -3 charge. And again, because this is a rule of thumb and not something that's always true, the generalities will typically hold to the elements that I'm going to fill in now. The trend in the negative charges is a little bit inconsistent. The trend in the +1 and +2 charges for your alkaline metals and alkaline earth metals is very consistent. And one final charge that's worth remembering is for aluminum. Aluminum typically makes a +3 charge.